superconductors is a material which has infinite conductivity and zero resistivity. Actually, it is found out at very lower temperatures that some materials below the critical temperature show the infinite conductivity and their resistance drop to zero and the current does not decay with time. It means the superconductors have infinite conductivity and zero resistivity, and the main thing is that superconductors behave like a pure diamagnetic substance. It means they do not allow the magnetic field of lines to pass through them. They expel out the magnetic flux, and this effect of expelling out the magnetic flux is known as the Meissner effect. This is known as the Meissner effect. इसको हम क्या बोलते हैं? Meissner effect बोलते हैं. And the magnetic field do not drop abruptly नहीं drop करेगा superconductor की boundary से middle में, but there is a exponential decrease in the magnetic field. There is the exponential decrease in the magnetic field, and the superconductor obey the isotope effect. It means if we increase the isotopic mass, so there will be decrease in the critical temperature. What is critical temperature? The temperature below which the superconductors are formed. That is the temperature below which the material changes into its superconducting state. So if mass get increased, the critical temperature got decreased. That is inverse relation is there. And what is the reason? That is electron-phonon interaction is responsible for the phenomena of superconductivity. Like this, normal conductors have this type of graph. They have infinite resistance even at very low temperature. Even at very low temperature, the superconductors, normal conductors have finite value of resistance, but superconductors have their resistance approach to zero below the certain critical temperature, and that means it very strong. And you need to remember, if you apply a very strong magnetic field to the superconductors lose their superconducting phenomena. It means at a sufficient high value of magnetic field, the superconductors get converted into the normal conductors. And now the superconductors are of two types. There is type 1 superconductor and there is type 2 superconductors. Type 1 superconductors are known as soft superconductors, and they show the Meissner effect very properly. What is the Meissner effect? That is the diamagnetic behavior. They are perfectly diamagnetic and they show the Meissner effect. They follow it very strictly like this. They show the superconducting phenomena, and at a particular HC they convert into the normal state. I told you na, at a particular value of magnetic field they abruptly change into the normal. So that is the type 1. But in the type 2, they do not change abruptly. There is a vortex state in between. There is a vortex state in between in which the magnetic field is not zero. So there is intermediate state. Vortex state is the intermediate state in which the magnetic field is not zero. That is known as a vortex state. तो ये जो मैग्नेटिक फील्ड वैल्यू मैग्नेटिक फील्ड अप्लाई करने पे एकदम से नॉर्मल कंडक्टर्स बन जाते हैं, ये है टाइप 1 सुपर कंडक्टर. तो इनकी इतनी कोई खास एप्लीकेशन नहीं है, क्योंकि सिर्फ 0.1 टेस्ला क्रिटिकल मैग्नेटिक फील्ड पे ही ये नॉर्मल कंडक्टर्स बन जाते हैं. तो इनकी कोई खासी एप्लीकेशन नहीं है. लेकिन अगर मैं टाइप 2 सुपरकंडक्टर्स की बात करूं, दे आर हार्ड सुपरकंडक्टर्स. दे डू नॉट फॉलो द मीजनर इफेक्ट वेरी स्ट्रिक्टली एंड दे डू नॉट जंप टू नॉर्मल स्टेट वेरी अब्रप्टली. वो ऐसे एकदम नहीं नॉर्मल स्टेट में कंडक्ट हो जाते, इसीलिए इनकी प्रैक्टिकल एप्लीकेशंस ज्यादा है एज कंपेयर टू टाइप 1. एंड लार्ज मैग्नेटिक फील्ड इज रिक्वायर्ड इन ऑर्डर टू डिस्ट्रॉय देयर सुपर कंडक्टिविटी. उसमें थोड़ा सा मैग्नेटिक फील्ड लगाते ही सुपर कंडक्टिविटी डिस्ट्रॉय हो जाती थी, लेकिन इसमें ऐसा नहीं है. यू हैव टू अप्लाई लार्ज मैग्नेटिक फील्ड इन ऑर्डर टू डिस्ट्रॉय द सुपर कंडक्टिविटी. इसीलिए हम इनका फ्यूजन रिएक्टर्स बनाने में, ठीक है, हाई मैग्नेटिक फील्ड